All right, this shows us we're recording this blue dot right here, okay? All right, let's get a few things straight with this review on 2.6 and 2.7. If you are adding and subtracting like I am here, adding, you can only add and subtract like terms. You can multiply and divide anything. The only time exponents change is when you're multiplying the variables together. For example, what is x times x? X squared. Top cloud, okay? What is x plus x?
2x.
2x. When did I change the exponent? When I multiplied. X times x became x, what? Squared, right? All right, so in this case, I'm combining like terms. What is 9a plus 7a?
16.
16a. I just added the coefficients. All right, problem number 2. All right, let's talk about another problem we're having. Signs, positives and negatives. When you are adding and subtracting, you know, I realized that when you were in first grade, they told you that this symbol meant for you to add or put together. Because you couldn't understand integers at that time, positives and negatives, they later told you that this sign meant to subtract. And you may still think that. When you got to the 5th and 6th grade then, you still thought that this meant subtract. But you add. And then you looked at a problem like this, and you knew you had to subtract, but you may have forgotten to take the sign of the bigger number. What about if it was like this? You still going to add? Yeah, subtract. So up here we added, and down here we subtracted. So let's talk about why. These two that we added have like signs. And that's why we added or combined or put them together. It's like this. Owing money is a negative thing, right? If I owe you $3 and then tomorrow I owe you $4, you're not going to let me buy with just owing you $1. Right? You're going to make me pay the whole $7. They're like signs. You add, you put them together. All right, now down here, I did some subtracting, okay? Why did I subtract? Because they had different signs. It didn't matter which number was positive and which number was negative. Because they had different signs, I subtracted, and then where did I get my sign for my answer? Come on. Whatever the higher number has, right, if it's positive or negative. So here the higher number was positive 7, here the higher number was a negative 7, here the higher number was a positive 7. So if they have like signs, you add. If they have different signs, you subtract. Think about money. If I have $4, but I owe you 7, I still like 3, don't I? I can give you my 4, but you're still going to make me pay the $3 down here. If I owe you $4 and I have $7, how much do I get to keep? I get to keep $3. So think about it in terms of money. All right, now, with multiplication and division, like with this problem right here. To me, that rule is even simpler. Like signs is what? Positive. It doesn't matter if I have negative 4 times negative 3, the answer is what? Positive 12. But if I have different signs, my answer is negative. To me, multiplication division is simpler rule, but everybody's not got that in their head yet, okay? So if I have this problem right here, negative 2 times 8a, negative 2 times 8, that would be 16. And this variable, you don't have to have like terms to multiply. You multiply anything, the a just sort of comes along for the ride. It's part of it. It's part of this term. I just doubled this term. And because they have different signs, my answer is negative. Now, does this clear up any problems we're having with signs? Y'all not doing any head shaking, but I'm going to tell you, I discovered this morning in the second block, we were having trouble with this right here. And that's another reason I'm going to put this on a video so you can go back and hear it again. This is addition and subtraction. With multiplication, division, like signs is what? Positive. And different signs is negative. That's it. All right, going on to the third problem here. Number 3. Now, I still read that 15D minus 11D. That's where we read it. But when we look at that problem, we know that the 15D is positive and the 11D is negative, and I would subtract them and take the sign of the larger term. That's why it's positive. You're correcting your paper and you're making a key for yourself to study, right? Okay, good, because we're going to make an A on this thing. All right, now I'm multiplying and I have like signs, so my final answer will be positive or negative? Positive what?
18C.
Right. Question so far? Okay, what does that rule say? What does that rule say? They have different signs, so I would subtract, and 7 minus 5 is 2W, and the bigger term was, so negative 7, that's right, so it'd be a negative 2W. Now, if you're just writing down the answer only, and you're not really listening to the why, get the why. The why is how you're going to do the test tomorrow. Knowing negative 2W tomorrow is not going to help because that problem won't be on there. But to understand that we had to subtract them because they have different signs, that's the thing. This problem would probably, look better like this. Regardless, they're both positive, so my answer will be positive. I don't think anybody has ever taken two positives and just inadvertently thrown a negative in there for fun. Like I'm so negative happy. I'm just going to make that answer negative. It's probably a negative, but all the rest of them, if this like signs, we pretty much understand with two positives, we're going to get a positive answer. We're dividing, okay? And so this would be, what's 12 divided by 4?
3H.
So this is just going to be a positive 3H. To be honest, this problem right here was commonly missed. You know what people put? 12W. You know why? Because they thought that told them to add. But that symbol just means that 5W is positive, 7W is negative. Different signs, you do what? Subtract. All right, going on to number 7. Now, if you're still in first grade, you would say, okay, I've got to subtract this, right? That's what they think. But we know that these are integers, and they have like signs. They're both negative, so what would we really do? And the answer would be negative 17H. Very, very good. Stop me if you have a question. Does anybody have one? Is this helping you? Okay, that's what we're trying to do because we want a good grade tomorrow. All right, negative 6J times negative 9J. Now I'm going to go back to a question I asked you earlier. What is X times X?
X squared.
X squared. So what is J times J?
J squared.
You know what? People miss that. They put 54J, but it's 54J squared. Why is it a positive 54J squared?
Sons.
Because they have like signs. Oh, wow. Good job. Questions about any of that? Commonly missed problem. Y'all agree with that, looking at your own paper, right? Did anybody, raise your hand if you got number 8 right. 1, 2, 3, 4, 5. And it said 1, 2, 3, 4, 5, 6, 7. Pretty good. You know how many I had saying what? 1. But now you know. If you're multiplying variables, what do you do to the exponent? You change it. Over here, when we were adding and subtracting variables, did we change it? Nope. Nope. Okay. All right, next is number 9. We are adding 2 binomials. Now, what this sign tells me is that I'm just going to combine like terms. If this sign were negative, how would that affect this parentheses? Every sign will change. But if it's a positive, do I change anything? No. All right. So 4n plus 7, a positive 5n minus 6. And I need to stop and tell you something. This is not this sign. 5n is positive. That's where I got this. Whatever sign this is, just comes down here. And you'll see what I'm talking about when we get to number 11, I think. Okay? But 4n and 5n is 9n, and a positive 7 and a negative 6. They've got different signs, so I would subtract them and take the sign of the bigger number. And that's how come. Alright, that's why we're going to get what we get. Some people put 13 right here. What did they do? They added 7 and 6. They didn't pay attention to the signs, okay? What property? Yes. All right. And so, remember our rules for multiplication. Like signs is positive. Different signs is negative. So what's negative 11 times m? Good. What's negative 11 times negative 2?
22.
Positive 22. A lot of times with the distributive property, we just have a habit of just taking whatever's here and just bringing it down. That has nothing to do with it. This is negative times this negative. Like signs gives me this positive right here. I'm going to do this on the next page because I'm going to make sure you understand number 11. So I'll have plenty of room. Alright, this sign is saying combine them together, not add them together, okay? So am I going to change any of these signs over here? Right, no, I'm not. So I'm going to bring this down. Alright, here's what I meant earlier. We don't just drop whatever's here straight here. What is 2q, positive or negative? Is that good? We had a long discussion on that this morning. They were like, I don't understand how these signs here go together to make that. Subtraction is defined as adding an opposite or adding a negative, if that helps you. This is going to say negative. Its sign was negative. This did not say to find the opposite of. So I'm not going to change those signs. I'm just going to keep them like they were, just like I did here. Alright, 4q minus 2q would be 2q. And 3r minus 2r is plus 1r. And you can put that 1 there if you want to. Alright, questions about that one? That was commonly missed. What's x times x? X squared. What was j times j? J squared. What's g times g? G squared. So negative 1g times positive 3g is negative 3g squared. And negative g times negative 1 is plus g. Again, I have to draw this to say commonly missed. Probably I could have done that to number 11 also, to be honest. Okay, questions? Are we good? Are we better than we were? All right, number 13. Number 13 brought up this issue, and I thought this was a great question. The question was, do you always, when you have a negative here, is it always the second one you change the sign? And I got to thinking. Ignore this, we'll come back to this in just a second. But what if and maybe I should give a problem like this. Do I change the second one? Do I change the signs over here? How do I know which terms to change their sign? I look at where the opposite of is, right? A negative in front of front of parentheses means to find the opposite of. So wherever this is, I would change the signs of whatever that's in front of. Does that make good sense? Alright, so this part, I just bring down, that doesn't have an opposite of in front of it. But the opposite of positives will be negatives. And what variable did we put first and why? A comes first in the alphabet. So 7A minus 4A is good. And we subtracted not because that told us to, but because they had different signs. And 3B minus 3B is 0. Is there a B left? Do I write a B? No. It's like this. If I had a banana and I ate the banana, is there a banana left? Or is there just 0? There's 0, okay? So 3B minus 3B is gone. I have just a 3A left. What property is this? And I have a negative times a negative on both of them, right? Be careful. So what happens to 3M? Bring it down. Am I going to multiply it? No, it's not beside any parentheses. So that's not the distributive property. All right, negative 2 times negative 5M is positive 10M. Negative 2 times negative 8 is positive 16. Do you see any like terms? Are they both positive? Would we add those together? What would we get? A lot of people that miss this problem just brought down that negative 8, I think. Just forget. The distributive property, we have to be careful. Any questions? Okay, let's do this one. 15. 22x plus 33 divided by 11. They share a denominator of 11. I could not ever cross cancel over a plus or minus sign. Can't do that. So this means that 22x has a denominator of 11, and 33 has a denominator of 11. And if I reduce this, what do I get? 2x. And if I reduce this, what do I get? Plus 3. Most people got that problem. That was a commonly correct problem. I probably didn't say that the best, but that is most likely correct on people's paper. All right, let's take a break and go to break. All right, let's look at number 16. All right, what does this sign tell us?
Everything in parentheses changes.
The opposite of, right? Does it tell us to subtract?
No.
All right, so 5G is negative, 2H is positive. 6G was positive, now it's negative. That's not this sign. That's the opposite of whatever this was. And then the opposite of 5H is negative 5H. Okay, now what comes first, G or H?
G.
There you go. All right, so negative 5G and negative 6G is negative 11G. And 2h and negative 5h is
-3 H.
questions.
Did you have to say alphabet?
All right, number 17. Remember, this means that they share a denominator. Okay, so both terms, 50m and this negative 25, share a common denominator of negative 25. So I wouldn't want to cancel out. So 50 divided by 25 is 2. Why would my answer be negative? Because they had different signs. However, these have same sign, so this would be positive. Anything divided by itself is a 1, right? Questions? Are you getting anything more than you had? Okay, you're making a key. We're going to rework these problems. All right, number 18. What does this symbol on the outside of parentheses mean? Opposite of. It's on the outside of this one, but not this one. So negative 7r plus s stays the same. And the opposite of a negative 3r is a positive 3r. And the opposite of a negative 2s is a positive 2s. Alright, let's put the r's together. Different signs, so we would subtract. What would our answer be? Negative 4r. What's positive 1s and positive 2s? Plus 3s. Questions? We good? All right, number 19. Is H the distributive property here? No. Why not? What is separating them? This sign. What does this sign mean? The opposite of. So H I just bring down. And then I find the opposite of a positive 4H. And the opposite of a negative 1. And what is 1H and a negative 4H when you put them together? Negative 3. And we subtracted because we had different signs. And why can we not, by the way, why can we not put these two together? They are not like terms. That's wrong. With adding and subtracting, you have to think about like terms. Not multiplying and dividing, but adding and subtracting you do. Questions about that? All right, number 20. What property is this? Distributive. What's x times x? X squared. What was j times j? What was g times g? So what's y times y? So negative 3 times 2 would be negative 6 y squared, right? And then negative 3y times 5 would be negative 15y. Why can I not put these two together and get a negative 21 something? Because they're not the same something, right? They are not like terms. I cannot put them together if they are not like terms. Questions on number 20? 21, I'm asked to find the perimeter. How do I find perimeter? Add up all the sides. Okay. Well, there's 2 lengths. And there's 2 widths. So I will do the distributed property here and here, then start combining like terms. 2 times 3R is 6R. 2 times 5S is, come on, 10S, good. 2 times 2R, 4R, and 2 times S is 2S. You know, the good thing about that problem, there were no negatives. Did you notice? I left off the S right here, guys, for the 10. Okay, how many R's do I have? In all? 10. How many S's? Questions at all? What if I just put 3R plus 5S plus 3R plus 5S plus 2R plus S plus 2R plus S? Would that be okay? Yeah. I didn't even have to use the distributed property. I could have just written out all the sides. 22 is also perimeter, but this time it is a triangle, so I just add up the 3 sides. X plus Y, 2x plus 2y, 2x plus y. How many x's do I have in all? 5. 2 plus 2 is 4, plus 1 is 5. How many y's do I have in all? How many? 4. That's it. Questions? Nothing? Could y'all make 100? Could you make a lot better? Okay. Now we're finding area. Area is equal to length times width. What's x times x? X squared. What's j times j? G times g. Oh, what's my last one? Y times y. All right, a times a. All right, so this answer is 12a squared, and then units squared, whatever the units were. Because we weren't given them. I didn't take her grade, so we're good. All right, area is equal to 1/2 the base times the height in a triangle. If I was going to measure how tall this room, the height of this room, would I start at that bottom corner over there and go diagonally all the way to the top corner over there to find out the height of this room? How would I find the height of this room? What if I did it like this? Would it be okay if I kind of did it a little diagonally? Common sense. How would I measure this room? Straight up. Would this vertical line be perpendicular to the floor and to the ceiling when I finish measuring? Y'all with me? All right, so anytime you have a perpendicular, you've gotten height. This is the H. This is the height. This is the base. So area is equal to 1/2 times the height times the base. I'll reverse those. Is that okay by the commutative property if I reverse those? Here's why I did that. What's half of 8? 4. What property is this? So what's the final answer? 4a plus 12. You are exactly right. And that would be units squared since this is area. Does anybody have any question at all? Yes, ma'am.
So this multiplies where you start it?
If I multiply the same variable times itself, like if I have x times x, that's to the first power, that's to the first power, I add them together.
That's the only time you do that then?
Yeah. Later on in chapter 8, we're going to learn this. Really what I did was add those. So what would x squared times x to the third be? Yeah. That's chapter 8. Any other questions on any problem on the whole thing? All right, get your papers out. Let me come around and look at them.